All right, so one of our last ones that we're going to take a look at is where we end up finding low amounts of kinetic energy. And again, our equation for kinetic energy is 1/2 times mass times velocity squared. And again, if we're using this ball right here, our mass doesn't change, it stays exactly the same. So the only thing that we're going to affect with the kinetic energy is the amount of velocity it has. So where during this system is my velocity basically nothing? That's what we're looking for. If we're looking at the lowest amount of kinetic energy, we're looking to find where our kinetic energy is 0 or at its lowest. So as we're watching this thing oscillate or move back and forth, we got to think about motion a little bit, and we got to think about where are we moving the slowest at, even if it's for a brief amount of time. And what we have to do is we got to freeze frame it. When we get to here and this thing decides to get to its highest point and then go the opposite direction, we got to think that it has to be at 0 for at least a moment of time. When I say 0, its velocity's got to be 0. So it's speeding up, speeding up, speeding up, slowing down, slowing down, slowing down, and when it gets to the edge, then it starts speeding up again. Well, for a brief moment of time, this thing has to have a velocity of 0. And if it has a velocity of 0, if I plug into that equation, 1/2 times mass times velocity squared, that means your kinetic energy is going to be 0 as well. So again, we found that at its edges, so when it's at its highest point, which right here, this will be my highest point, its potential energy is its highest, but its kinetic energy will be at its lowest, at least with this pendulum system.